Wow, we got a lot of words here. So let me set this up. Let me set this problem up for you by drawing a picture here. So let's see. You have a container of water. Okay, this would be my container, like a beaker or something, and it's full to the brim with water. All right, and it's sitting in some sort of a basin so that it catches the water. That way we can measure it. And then we've got 3 rubber balls, and they're dense enough that they'll sink in the water, so they won't float. All right, so we have a small one, and then we have a medium one, and then we have a large one. Okay, small, medium, large. All right, so what do? First of all, we take the small rubber ball, and let's just say it's suspended by a really thin string or something. That way, when we submerge it in the water, we won't have trouble getting it out. We'll just pull it up by the string, and the string doesn't have much volume. So what we do is we take the small ball and we dip it down into the water, and some of this water then overflows into the basin. Okay, and then we're able to measure how much of the water overflowed the container. Okay, and so we do that first of all with the small ball. All right, and then after we do it, we still have this um, container, and we have this basin that it's sitting in. Okay, and now the water level has dropped because some of the water overflowed. Okay, and then we take the medium ball. Okay, let's say that it is also suspended by a string or something, and we dip that into the water. Okay, and at first the water level just rises up until it gets to the brim, and then it starts to overflow. All right, so we didn't add any water between when we dipped the small ball and then we dipped the medium ball. Okay, so we completely submerge the medium ball, some water overflows, and then we can measure it. All right, and then finally we do the same thing with the large ball. Okay, so we have the container, and it's sitting in a basin. Okay, we take the large ball. Okay, now after we did this medium ball, the water level went down again. Okay, so maybe that's a little too low, but you get the idea. So the water level went down again. We have this large ball suspended by a string. We dip that in to the water, and the water level rises, okay, until it reaches the brim, and then it overflows. Okay, and we can measure that amount of water. All right, so that's basically the setup of the problem. And I am going to let S be the volume of the small ball. Okay, the volume of S. I'm going to let M be the volume of the medium ball. And I'm going to let L be the volume of the large ball. Okay? So, all right. So we've measured the water that overflows into the basin each time. All right? And we're given some information about that water. All right? It says that the volume of water that overflowed when you put the small ball into the container is 3 times the volume of water that overflowed when you put the medium ball into the container. Okay? So let's write that out in mathematical terms. So the volume of water that overflowed, so the amount that's going to overflow when the small ball is dipped into this container that's full to the brim, is going to be the volume of that ball. Okay, so that's the volume of water that overflows. And we know that that's 3 times the amount that overflows when we dip the medium ball in. Okay, and when we put the medium ball in, first of all, the water level rises up to the brim, and then it overflows. Okay, so the amount of water that overflows when the medium ball is dipped into the water is the volume of the medium ball minus the volume of the small ball. Okay, because the small ball has already displaced some of the water. Okay, and so it won't overflow until the volume that has been dipped of the medium ball exceeds the volume of the small ball. Okay, so that's what this statement tells us here, that the water that overflowed when they put the small small ball in is 3 times the volume of water that overflowed when you put the medium ball in. Okay. So, let's do some rearranging. Let's just work with this first of all. I'm first of all going to distribute the 3. Okay. So this is the same as S is equal to 3m minus 3s, just using the distributive property. And then, let's see, we can add 3s to both sides. Okay, we can combine all the s terms together, and we get that 4s is equal to 3m. Okay, so now we essentially know the ratio of the volume of the small to the volume of the medium balls. Okay. Or we could also write this as the volume of the small ball is equal to 3/4 of the medium ball's volume. Okay, same thing. All right, so let's look at this next statement. It says the volume of the water that overflowed when you put the large ball into the container is 2 times the volume of water that overflowed when you put the small ball into the container. All right, so now the amount of water that overflowed when you put the large ball in the container is going to be the large volume minus the medium volume. Okay, because the water that's displaced already is the volume of the medium ball, right? And so when we dip the large ball in, it's not going to overflow until the volume that's displaced is larger than the medium ball. Okay, so it's not going to start to overflow until we've displaced the amount of the medium ball, or the volume of the medium ball, and then so the volume that overflows when you dip the large ball into the water and submerge it completely is the large minus the medium volumes. Okay, and it says that that is equal to twice the volume that was displaced or that overflowed when we put the small ball in. Okay. So, all right, let's do a substitution here. I actually have the volume of the small ball in terms of the medium ball, so I could actually substitute this value here and put in 3/4 s. Okay, so that's 2 times 3/4 m, I mean. Okay, 3/4 m, and that's the same as 3/2 m. Okay. So now I have everything in terms of the large and the medium balls volumes. And so let's rearrange this. I'm going to add m to both sides. Okay. So the large is equal to 3/2 plus 2/2, essentially. 5/2 m. Okay. Or I could write that as 2L is equal to 5M. I could do that. All right, so now we want to get the ratio of all 3 balls to each other. So let's rewrite these a little differently, actually. So I could take this equation here, and I could write that as the ratio of the small to the medium is equal to 3/4. All right, and I can take this equation right here, and I can say that the ratio of the medium to the large is equal to what? It's 2/5. I guess large over medium is 5/2, and medium over large is 2/5. Okay. But you see how we've got here the medium in terms of 4, and here we have the medium of 2 in terms of 2. So let's put them on the same terms. So this is the same thing as 4/10, right? So now we can just express the ratio of the small to the medium to the large as, so small to medium to large is equal to 3/4/10. Okay, so now we've got them all expressed as one ratio. So there you go. So that's the ratio of the 3 balls, the small, medium to the large.